So good morning students. I am Santan, working as a physics faculty in Target English Medium School. In our previous video, I am clearly explained about what is net force, how we can find the net force in the different cases. Now in this video I would like to explain about what is the visualizing magnetic field and what is the free body diagram and how we can find net force in free body diagram. The topics or concept I would like to explain in this video. Now come to that one. First one, our topic is visualizing magnetic field. So means visually how we can see the magnetic field, that is the meaning of this one simply. So for showing of this one, what we can do here means so first of all, we can take a large drawing board. Drawing board is mainly made up of the wood. So first of all, we can take a drawing board. At the middle of that, after that, now we can take a white chart. A white chart will be placed on the drawing board. Further, now we can take a bar magnet. We know that every magnet has two poles. One is the north pole, another one is the south pole. Listen very carefully. So first of all, we can take a white drawing sheet. It is fixed on the wooden board. Now we can take a bar magnet. It has the two poles, north pole and the south pole. It will be placed on the drawing sheet at its middle. So now after that, what we can do? Now we can take some iron fillings. Here, what is the first one here? Bar magnet. First one. Second one, drawing chart. Which color? White color mostly. And third one is drawing board. Fourth one is iron fillings. Means the small piece, tiny pieces of iron. That is the meaning of that. That's why to observing the visualizing concept in case of magnetic field. So we want some materials. What are that one? Means bar magnet, drawing chart, drawing board and iron fillings. That's why first of all we can take a white color drawing chart that is fixed on the drawing board. Further, now we can take a bar magnet. The bar magnet is placed on the drawing chart or sheet at its middle. After that one, now we can take some iron fillings. But before going to this one, what we can do here means so the magnet you must be placed along the earth magnetic field. So what is along the earth magnetic field means? We know that it is the east, west, north, south. That's why if you can keep the magnet like this mode, so like this mode means so it is the north side, it is the south side according to our position. It is the east side, it is the west side. But when the magnet is placed like our consider direction like north and south means it is not exact direction because why? Because means so slightly the north in one particular direction is there. How we can say the north is not like our considered position. It is slightly this position is there means so we know that the position of the earth is continuously changes due to its motion. Now, but here one thing we have considered that, but the directions are constant. But in our particular position means when we can do the any experiment by using the magnets at that time. So you must be use a magnetic compass. What is the use of a magnetic compass? With help of the magnetic compass, we can find the direction of the earth magnetic field. Means so what is the exact north? What is the exact south? That is easily we can find out. Not only that one, east and west also, but mainly with help of the magnetic compass we can find exact north south direction. That's why the needle in the magnetic compass is showing in which direction along the north and the south. In that direction we place our magnet. In remaining also it will be coming. But when you can do that type of way, we can observing very clearly. And also when you can draw the lines, it will becomes in one particular exact shape. For that purpose, I am saying that the magnet is kept along the direction of Earth magnetic field. So once again listen. First of all, we can take a white drawing chart. It will be fixed on the drawing board. Further, we can take a bar magnet. The bar magnet is placed on the drawing sheet at its middle. Now, after keeping the bar magnet with help of a magnetic compass, the bar magnet position we kept exactly along the north-south direction of the Earth magnetic field. And finally, now we can take a tiny pieces of iron. It is called iron fillings. Iron fillings are sprinkled on the cardboard sheet around the magnet uniformly. Listen carefully. Sprinkle the iron fillings on the cardboard on the drawing chart uniformly. Now here we are observing that. Now slowly tap the what is that one drawing chart on the drawing board. When you can slightly tap the drawing chart, we are observing that immediately so iron fillings are comes in one particular shapes. Like in different modes are there. Like this. Here we are observing that this is not exact for understanding of you. When you can observe this type of one, what you are understanding means so more iron fillings are stick to the magnet where at the poles, at the end of the poles means at the end of the north pole, at the end of the south pole, more iron fillings are sticking to that. But the remaining at the middle of the magnet means between the north to south ends, you are observing that less iron fillings are sticking or attracted. So from this one, what we can understand means in every magnet, the pole strength means the magnetic pole strength is very high at the end of the poles and less at the middle of the bar magnet. Listen very carefully. So the strength of the magnetic field that is called pole strength. The strength of the magnetic field is very high where at the end of the poles, at the end of the north pole and end of the south pole, and the magnetic field attraction is less where at its middle. That is we are clearly understanding after completion of observing this situation. So how we can find the visualizing the magnetic field means with help of the iron fillings are attracted by the magnet and showing one particular directions. Based on that one, we are visually, means with help of our eye, we are seeing, okay, this magnet will be having some magnetic field. Magnetic field is nothing but a region or a place around the bar magnet. Okay, so every magnet is having some attractive or repulsive nature around its in a particular region, that is called magnetic field. Simply, every magnet has attractive or repulsive force, or maybe every magnet has attractive or repulsive force around its in a particular region. That region we are called, what is that one? Magnetic field. That's why, so in this region we are observing that all the iron filings are, okay, are showing in particular directions. At the same way, what you can find here, okay, so before going to that, once again I will explain. So how to, okay, showing the visualizing magnetic field means, first of all we want some materials, bar magnet, drawing chart, drawing board and iron fillings. First of all, we can take the white drawing chart. It is fixed on the drawing board. Now we can take a bar magnet. It has the two poles, north pole and south pole. It will be placed on the drawing chart at its middle. Now the bar magnet you, okay, fixed on the drawing chart along the direction of north south of the earth magnetic field with help of the magnetic compass. Next, finally, now we can take some iron fillings. Iron fillings are sprinkled on the cardboard sheet uniformly or on the drawing chart uniformly. Now, if we can slightly tap the drawing chart, okay, on the drawing board, we are observing that iron fillings are, okay, attracted by the bar magnet and showing one particular directions. Okay, like this type of mode. After, okay, showing the magnetic field, okay, by the iron fillings, what we can say, that means what we are observing, more iron fillings are sticking at the end of the bar magnet and less is sticking at the middle of the bar magnet. That's why from this visualizing of magnetic field, we made two observations. First one is, what is the first observation? More number of iron fillings sticking at the end of the two poles. That is the first one. And second one is, lesser iron fillings are attracted by the middle of the bar magnet. That's why from that one, what you are conclude or understand means, every magnet, okay, has more attractive force or more strength, okay, at its ends. That's why number of iron fillings is, okay, attracted by its ends and sticking more here. And the middle of the bar magnet has a less attractive force than the end of the bar magnet. That's why lesser iron fillings are sticking to the bar magnet at its middle. That is the, okay, means with help of the visualizing magnetic field, we are clearly understanding that, okay, a magnet has having, okay, attractive force or not. If that attractive force, okay, where attractive force is more and where attractive force is less in case of magnet, that is we are clearly understanding in the concept of visualizing magnetic field. Next, our topic is how to find net force from free body diagram. Okay, so first of all, I would like to explain what is the free body diagram and how we can find the net force. So free body diagram means the diagram showing all the forces acting on it at any instant is called free body diagram. Listen very carefully. The diagram showing all the forces acting on it at any instant is called free body diagram. The free body diagram, simply we can write FBD, means free body diagram. So by using the free body, in case of free body diagram or by using the free body diagram, how we can find the net force is acting on it along the x direction and y direction. That is we discussed with the help of one small free body diagram. So just we are consider it is a car. Okay, a car is moving on the road. Listen very carefully. It is a road. It is a car. A car is moving on the road. At any when a car is moving on the road, how many forces are acting on the car? That is first discussing that. If the car is in motion means here this side is engine, it is the rear part, we know the rear side. It is the front, it is the back. That's why car is moving in which direction? Like this direction. That is that when the car is moving like that direction. Listen. Okay, when the car is moving in this direction, we are observing that here. Okay, here engine is there. If a car is in the motion means which is play a key role here or main role. So car engine is giving certain energy to the car. Then then the car will be moved into in motion. That's why here. So that's why what you can write here means so this direction which is acting engine force. Okay. Next, we know that if a body is moving on any surface, during such condition, to the opposite of the motion body, one force is acting. What is that one? Frictional force. So always says that friction is a force. It is always acting in opposite direction of a motion of a body here. So the car is moving towards the east side direction. In this one, engine force is helpful to moving into the forward direction. But in the backward direction of the car means opposite of the engine force on the tires by the earth, frictional force is acting in backward direction. At the same way, on the engine, which force is on the car, which force is acting downward? Gravitational force. That is called weight of a body. So it says that so on a body some gravitational force is acting vertically downward. That is we are considered as W, means weight of a body. So means earth attractional or earth gravitational force is acting on a body vertically downward. That is called weight. Now at the same way here, one more thing. The surface of the road, it is very, that it is a rigid. That's why when a body is placed over on the rigid body, the rigid body surface is applying some force in vertically upward against or opposite to the gravitational force. That is, we know that normal force. That's why here, this is the front row tires, this is the rear tires. That's why front row tires means normal force is acting vertically upward. N2 normal force is acting vertically upward. That's why. So means totally 4 tires are there on each tire. Normal force because of each tire of the car is contacted with the floor of the road, means surface of the road. That's why on the tires, normal force is acting vertically upward. On the front road tires of the 2 tires, N1 force is acting vertically upward. At the rear wheels, N2 force is acting vertically upward. Now, okay, after seeing this diagram, what you can understanding, when a car or when a vehicle is moving on the road, okay, at any instant, okay, how many forces are acting? Mainly 4 forces are acting on that one, okay. 2 forces are acting along the horizontal and 2 forces are acting in the vertical ways or vertical direction. Which forces are acting along the horizontal? Force applied by the engine and frictional force. These two are acting in the horizontal direction but in opposite direction. In horizontal way but in opposite direction. Next, in the vertical mode, gravitational force is in downward, normal force is in upward. That's why in the vertical way also 2 forces are acting on the car, okay, but they are in opposite direction. That's why now come to that one. Net force along x direction. Net force along x direction. That's why what is the first one here? Okay, along the direction. So simply here we can write f of net force is equals to, okay, so f of net is equals to what we can write here? Force applied by the engine. Okay, force applied by the engine we are considered as a capital F. Frictional force we are considered as a small f. Okay, that's why f of net is equals to, here car is moving which direction? Forward direction. Means force applied by the engine is more than the frictional force. That's why we can take what is that one? Capital F minus small f. Means force applied by the engine minus frictional force. Minus is represented here opposite direction. Okay, next, second one is net force along which direction? Y direction. Y direction is nothing but in vertical mode. That's why f of net is equals to, here, okay, n1 and n2 is are acting in upward direction, gravitational force is acting vertical direction. That's why what you can write here, n1 plus n2, these two are acting in upward direction. For these two forces, W means weight of a body by the gravitational force of the earth is acting which direction? Downward direction. Means for these two forces, this force is in opposite direction. These are the formulas to find the net force is acting in a free body diagram. Listen very carefully. What is the free body diagram? The diagram showing all the forces acting on it at any instant, that is called free body diagram. It is represented, or it can be written simply FBD, free body diagram. Okay, now with help of this example, you can easily understand how we can find the net force, okay, from a free body diagram. So just let we consider a car is moving on the road. Okay, so that's why at any one instant we can say that due to the force applied by the engine, the car is in motion. At the same way, when the car is in motion on the road will be applying some opposite force on the motion of the car, that is the frictional force. Means, okay, for engine force, frictional force is in which direction? Opposite direction. At the same way, okay, means force applied by the engine and frictional force, these two forces acting on the car in horizontal way. Okay, and at the same time on the car, gravitational force is acting vertically downward, that is called weight, and normal force is acting on the car, okay, through the tires, that is the which one? Vertically upward. Here we are observing that normal force means, once you remember clearly, okay, what is the normal force? A force exerted by a rigid surface, okay, on the other body when it is placed on it. That's why the car is a rigid, okay, one of the weight body or rigid body, it is placed on which one? Road. That's why road surface is also, it is very rigid, means strong. Okay, that's why the road will be, means here in the total entire the car, only the tires only touches to the which one? Road. That's why on the tires some force is exerted by the, Okay, surface of the road is vertically upward opposite to the gravitational force. That's why N is nothing but normal force. On the front two wheels, N1 normal force is acting vertically upward. On the rear wheels, N2 normal force is acting vertically upward. That's why. So in horizontal, two forces. In vertical, two forces are acting. Totally, how many forces are acting? Four forces. That's why it says that. What is mean by net force? If two or more forces is acting on a body, that is called net force. That's why here horizontal 2, vertical 2. That's why we must be consider net force concept here are applied. That's why. So net force along the x direction. So f of net in which direction? X direction. Okay, simple here x direction. Here y direction is equals to force applied by the engine is considered as a capital F and frictional force is minus F. For the force applied by the engine, friction is in opposite. That's why F minus small f. Next, net force along the y direction. That's why N1 plus N2. These two forces acting on the car vertically upward. For these two forces, gravitational force in the form of weight acting vertically downward. This is the formulas to find the net force from a free body diagram. But during the examination, what they are asking means simply, okay, I am observing clearly in some of the question papers. Okay, so just they will be mentioned in one. A vehicle is moving on the road. When it is moving on the road at any instant time, how many forces are acting on it? Write the names. Okay, write the names means you can write simply. Okay, so when a body is moving on the road, okay, during that condition, totally four forces are acting. Two forces are in horizontal direction, two forces are in vertical direction. So first you can put x direction or horizontal in x direction. Which forces are acting? Force applied by the engine, frictional force. Next, in vertical direction or y direction, gravitational force and normal force, like that one. Or sometimes means only they are asking that for 4 marks mainly. Okay. So draw a free body diagram and showing how many forces are acting on it at any instant. That's why just you can draw only this diagram, then you can get the 4 marks. So now I am giving a small homework for you based on the net force concept and the free body diagram concept. The first one thing is here these are represented steps. It is a stick, that is either wooden or iron, whatever the stick. A stick is placed on the steps as shown in this figure. Okay, now we can show the where normal force is acting. Listen very carefully. Okay, a stick is placed on the steps as shown in this figure. Okay, so now on the stick where the normal force is acting, you can show in the diagram. That is the first thing. And second thing is so just okay. The second one is a monkey is freely hanging from a rigid support through the rope. Listen very carefully. Okay, a monkey is freely hanging through a rigid support. Sorry, with help of a rigid support through a rope. During this condition, which forces are acting on the monkey? That is, we can write down here. Listen very carefully. So a monkey is hold the rope like this one. Okay. So maybe it is moving either upward or it is in the constant rest position only by holding the rope. During such condition, okay, how many forces are acting on the monkey? Okay, during holding the rope, we can draw the free body diagram. Means simply you are showing how many forces are acting on the monkey. Listen very carefully. What is the first one? A stick is placed on the two steps like as shown in this figure. On the stick at where the normal force is acting, we can show in the diagram. Next, second one is a monkey is freely suspended with help of a rigid support through a rope. Is nothing but simply a monkey is hold the which one rope. Maybe it is either climb or it is in the rest position by holding. During such condition on the monkey, how many forces are acting? We can show in the diagram. So first you can try your level best. Okay. So if you cannot find the answer, how to draw this one? Maybe first already explained clearly in case of car how the forces are acting on that car. Like that, with help of that concept, we can easily write down here. We know that normal force means vertically upward. It is acting by which one? Rigid surface. Okay. So here rope is having which force generally? One concept is there under which one? I will give you hint or clue to you. Under the contact force, one force is there. Okay, that force is having which one? Rope. That's why based on that concept and this diagram, we can easily draw the free body diagram or showing the forces is acting either on the stick and on the monkey. So even though you cannot understand how to draw the forces on this one, so you will be asked through the WhatsApp, my WhatsApp number, I will give the clarification.